Swimming used to kill people. Not from drowning, from the water itself. Before chlorine, every public pool was a breeding ground for typhoid, cholera, and dysentery. Here's how one bold doctor changed everything. In the late 1800s, cities built grand public pools as part of the clean city movement. Hundreds of people shared the same water every day. There was no disinfection. Pools were filled, used until the water turned foul, drained and refilled. Outbreaks were constant. In 1908, Dr. John Leal made a bold gamble. Jersey City's water supply was contaminated with sewage, and typhoid rates were alarming. Without waiting for court approval, Leal installed a chlorination system at the Boonton Reservoir, the first continuous chlorination of a U.S. water supply. The results were staggering. Bacterial counts dropped by over 99%. Typhoid cases plummeted. Within 5 years, over 800 American cities adopted chlorination. Typhoid death rates fell 90% by 1930. The swimming pool industry followed within a decade. By 1911, public pools started manual chlorination with calcium hypochlorite. By the 1920s, chlorination was standard practice. Health departments began requiring measurable chlorine residuals, chlorine that stays in the water continuously, not just a one-time dose. World War II accelerated everything. The military operated thousands of pools worldwide and couldn't afford waterborne illness among troops. They developed standardized sanitation protocols, specific chlorine levels, pH ranges, testing schedules. Many of the numbers CPO students learn today trace directly back to these wartime standards. When soldiers came home, the great suburban pool boom of the 1950s began. Residential pools needed something more convenient than dissolving granules by hand. That demand drove the development of Trichlor tablets and automatic feeders, the backbone of backyard pool care for the next 70 years. Now let's talk chemistry. When chlorine hits water, it doesn't stay as chlorine. It forms hypochlorous acid, HOCl. This small, electrically neutral molecule is the actual killing agent. It penetrates cell walls and destroys pathogens by oxidizing their enzymes and proteins. Here's the key fact. HOCl kills pathogens 80 to 200 times faster than its dissociated partner, the hypochlorite ion. Same element, wildly different effectiveness. And what controls which form you get? One thing, pH. This table is critical. At pH 7.2, 66% of your chlorine is the fast-killing HOCl form. At 7.5, it's 50-50. At 7.8, only 33% is active. And at 8.0, less than a quarter. This table shows up on the CPO exam in multiple forms. This is why pH control is more important than how much chlorine you add. You can dump chlorine into a pool all day, but if your pH is 8.0, 3/4 of it is sitting there doing almost nothing. Manage your pH first, then manage your chlorine. Over a century, the industry developed a whole family of chlorine products. Chlorine gas, the original, 100% available chlorine, but toxic and now restricted. Liquid chlorine at 10 to 12%. Cal Hypo at 65 to 78%, Trichlor tablets at 90%, and dichlor granules at 56 to 62%. Available chlorine content, ACC, is why a pound of one product isn't equal to a pound of another. It measures disinfecting power relative to pure chlorine gas. A pound of 12% liquid chlorine has 1/8 the killing power of a pound of gas. You need 8 times more. Studying for the CPO exam? Check out cpostudy.com for free practice questions and study guides. And if you need help with chemical dosing math, the PoolDial calculator at PoolDial.com does the conversions for you. Free chlorine versus combined chlorine. Free chlorine is the good stuff. HOCl and hypochlorite ion ready to kill pathogens. Combined chlorine has already reacted with ammonia and sweat to form chloramines. Chloramines are 40 to 60 times weaker, and they cause that chlorine smell and eye irritation. Every CPO student needs this formula. Total chlorine minus free chlorine equals combined chlorine. TC minus FC equals CC. If your total is 3 ppm and free is 2.5, your combined chlorine is 0.5 ppm, and that's above the 0.2 limit. When combined chlorine gets too high, the fix is breakpoint chlorination. Add 10 times the combined chlorine level in free chlorine to destroy the chloramines. If combined chlorine is 0.5 ppm, add 5 ppm of free chlorine. Below the breakpoint, adding chlorine can actually increase combined chlorine. Counterintuitive, but true. In roughly a century, we went from pools that regularly sickened and occasionally killed bathers to a system handling billions of swimmer visits per year. But chlorine is not a magic bullet. It demands understanding. pH, temperature, chlorine form, CYA levels, bather load. Getting it wrong has real consequences. If you're studying for the CPO exam, this is part 1 of our 5-part pool chemistry history series. Subscribe so you don't miss part 2 on the Langelier Saturation Index, and visit cpostudy.com for free study tools built for the CPO test.